Okay, so have you seen this notation before? Like the way it's written? Do you know what this is about?
You internet I'm telling the sequence user. I don't. We just do. We just change n into one.
Correct. So U1 equals, go on it.
7 plus 3 times one.
Correct. And that is?
10.
That's it. Let's do part B for the 10th term.
So you do U10 equals 100 minus 20.
Yeah.
Which is 80.
Perfect. Okay, that's fine. So just making sure you've seen that. Arithmetic sequence. Do you know how to work out the nth term for this sequence already?
Is it 4n minus 1?
1, 3, 4, 4n minus 1. How would you get, how would you check if 45 will eventually be in that sequence?
You just keep on adding 4 and get there.
So the quick way would be, so if you kept adding 4 and let's say it was the 17th term, like 17th number in a row,
Yeah.
what you could do is you could do 4n minus 1 equals 45 and then solve it to see.
Yeah, so then n would be 11.
Well, this is already minus 1, so how would you get rid of it?
Add the 1.
And what would you get?
So you have to do 4n equals 446, which you can't do.
Which you can't do, and so what does that tell you?
Tells you that it's not going to be in the sequence.
That's it. So n, it's like 11 and a half. And so you can see here, term 1 is 3, term 2 is 7. There's no term 1.5. Because like it would be 5, but 5 isn't in the sequence.
Yeah.
And so that's how you check if a term is in the sequence. Any questions about that?
No.
Okay. Let's see. This one. Any idea what the common difference will be for this first one?
I don't know what a common difference. Well, I don't know how to answer that question.
Like what they're going up in. You might not. So try. What are the first 3 terms for that one? 5n minus 2.
3.
Yeah.
8.
Yeah.
13.
What are they going up in each time?
5.
Yeah. And so that's because that's 5. It's like 5 times table. And then how about un equals minus 3n plus 4? Any idea about the common difference there?
We go 1.
Yeah.
And let's keep on taking. So minus 2.
Yeah.
Then minus 5.
And any idea what the common difference is there?
Not really, to be honest.
What's it going down in each time?
Oh, sorry. Yeah, it's going down in third. Fully meant between both of them.
Yeah. And so if it's going down by 3, we say minus 3. And so you can see for the first one, the common difference is 5 because that's a number in front of n. And the second one, the common difference is minus 3 because that's a number in front of n.
Yeah.
And so that's helpful for stuff. Nth term for these, you're going to be fine. How can you show that 596 is a term in this sequence?
You add 3 every time.
So that would take forever.
Does it just because that's a multiple of 3?
Okay, so what would be the nth term for this sequence?
5n plus 3. Sorry. 3n minus 2.
So first term would need to be 5.
Oh, plus 2.
Yeah. And how can you show that 596 will be in the sequence without adding 3 forever?
We just have to pick around Oh, so 3 times 139 plus 2.
So you could now that's part B, so that's a different one. Um, so you could like guess and check numbers, like trial and improvement.
Yeah.
Um, how could you solve to figure out exactly what n is for that one?
Do 596 minus 2.
Yeah. So basically, you make it equal to it. Okay. So take away 2.
Then divide that by 3.
Well done. 5, 9, 4, 3n, and then divide that by 3. I'm just going to use calculator. 4 divide by 3. Okay, 198. So n equals 198. What does that tell us about the sequence?
It's the 198th term.
Correct. Yeah. How can you show that 139 is not a term in this sequence?
Well, it is 7n minus 3.
Yeah.
So you could do that equals 139. It was meant to, but it can't.
Yeah.
139 add 3, which is 142.
Yeah.
And it's not divisible by 7.
That's right. So 7 goes into 14 twice, and then 7 can't go into that 2 left over, like 20.3 something or other. And so, yeah, n must be an integer. And so,
Yeah.
it's not. So 139 is not in the sequence.
Yeah, you're right.
Any questions there?
No.
Okay, so 139 not in sequence. So for these show that questions, you always have to copy and paste what they asked you to prove at the very end.
Yeah.
Okay, so exam question. Okay, let's try it.
The nth term of the sequence is 6n minus 3.
Mm-hmm.
So then you do 6n minus 3 equals 150.
Mm-hmm.
So you do 150 add 3.
Mm-hmm.
It's 153. And do 153 divided by 6.
Mm-hmm. And so n equals
That's not in the sequence, I've just done it in my head.
well, whatever it is, 25.5.
It can't be that, so he's not correct.
Yeah. Why can't it be that?
It's got to be an integer.
Correct. Not correct. N must be an integer. Any questions there?
Yeah.
Be integer. Okay, and I noticed this was a 1 mark question. So the method you used will always work. I noticed this was a 1 mark question, and I thought that's too much work for a 1 mark question. What type of number are all the numbers in the sequence?
Multiple of 3. 153 isn't.
Even simpler than that.
That all. I don't know.
So I think 150 is a multiple of 3. It's just that.
But all of them are odd.
Correct. So these are all odd, but 150 is even. Yeah, it's because it's the 3 times tables without the even numbers. There's no 6, there's no 12.
Yeah, because
And so your method will always work, and you have to do that for the higher mark questions. But sometimes for a 1 mark question, there's an easy thing. So linear sequences, x1/2 or tick?
I'd say tick.
Yes. This one I'll skip. Have you done Fibonacci sequences in school yet?
Yeah, I've done a bit of it. So would it be 2, 3, then 5,
Yeah.
8, and then 13?
Yeah, that's fine. Okay, exam question. How would you do this?
So you have to find the first term first.
You only need the 10th term.
So you replace n with 10.
Yep,
So it's 3 times. But you start off with 10 squared, don't you?
correct.
10 squared is 100. So you do 3 times 100, which is 300. Sorry. Yeah. Which is, add 7 is 307.
Well done.
Add 7 is 314.
I just wrote it. I just wrote it one underneath
Oh,
another.
yeah. Sorry. I don't know why I
Nah,
said
sorry.
that.
So that's 2 marks, and that's Bidmus, and so that's the beginning. Let me just check this one. What is the common difference here?
First difference is 7.
Mm-hmm.
Second one's 11.
Yeah,
The next one will be. It should be 13, but I know that it's not.
I think it's 15.
Yeah, that's 15. And then it is 19.
Okay, so that's first difference.
So it goes up in 4 every time. Or those numbers go from 4 every time.
Okay, so then the second difference is 4. Any idea how you use that to get the term-to-term rule for this one?
Well, it would be. Would it be 4n?
Okay, so this is a totally new thing. So I just need to do something else. Geometric sequence. Maybe someday I'll come back to those, but they're very difficult and they're totally new. No one's ever done them. I'm just gonna skip to quadratic sequences, and we'll do this. Skip way in. Where are we? Yes. So you know how the general form of a linear equation is y equals mx plus c?
Yeah.
Well, for a sequence, it's like dn plus c, like common difference. General form of a quadratic equation is y equals ax squared plus bx plus c, or for a quadratic quadratic sequence, instead of it being x, it's n. So an squared plus bn plus c. So using this one, an squared plus bn plus c, what would be u1 if you subbed 1 for n?
U1. It wouldn't just be. It would just be 1, wouldn't it?
So sub 1 for n. So u1 would be a times 1 squared plus b times 1 plus c.
So you do 9 plus 1 squared.
That's a.
Oh. So that would be equals A1.
Yeah, or just a.
Add B.
Yeah,
And C.
that's it. Okay, how about u2? So you're subbing 2 for n.
A4 or 4A.
Yeah, 4, right?
2B.
Yeah.
C.
And when you sub 3?
9A.
Mm-hmm.
3B.
Yeah,
C.
that's it. So what we have is a sequence. u1 is the first term, u2 is the second term, u3 is the third term, u4 fourth, and so on. The first difference is u2 take away u1, like term 2 take away term 1,
Yeah.
or term 3 take away term 2, and that's how you do those. So for our answers, what is u3 take away u2? And I have u3 on top and u2 on bottom.
5A.
Yeah.
Add 1B.
Yeah. 5a plus b. And then
Yeah.
how about u2 take away u1?
3A.
Yeah.
1B.
That's it. So that's the first difference. And then the second difference would be those two take away each other. So what is 5a plus b take away 3a plus b?
Yeah.
And what do you get?
2A.
That's it. You just get 2a. And what that proves is that the second difference is always 2a.
Yeah.
So 2a is the second difference. And so a is half of the second difference.
Yeah.
Okay. Maybe we could try something else as well while I'm here. What would be U0?
1.
No. So if you sub 0 for...
I thought that everything to the power of 0 is 1.
So it's 0 squared.
Which is 0.
Yeah. B times 0?
0.
And then plus C?
C.
Yeah. And so what that shows you is that U0 is C. And so just like with the other sequences, term 0 is C. So let's use that to solve these. Oh no, I'll go all the way back now to where we were. So here we were. So we said the first difference was this. The second difference was 4. So we just proved with algebra that the second difference is 2a. And so how can we use that to get what a is? And the second difference is 4.
So 4 equals 2A, then A is going to equal 2.
Yeah, a is 2. Any idea what the term before 4 would be in this sequence then?
2.
Let's see. So 7. No. So if we go back to here, you know how it was going a change of 4 each time second difference? So it was...
Oh, yeah.
So what would go before the 7?
A 3.
And so you would have to... So what would go before the 4 up here?
3. Oh, wait, no, 1.
1, that's it. And so we said that U0 is C, so that is 1. So in general, quadratic sequence, an squared plus bn plus c. We just said a is 2, so it's 2n squared plus bn plus c is 1. We now need to find b. We also said u1 is a plus b plus c. So the first term, 4, is equal to a, which is 2, plus b plus c, which is 1. So what is b?
U equals 2 plus B plus 1. So 4 equals.
Yep.
B would be 1.
Correct. So b is 1. And so what's our final answer for the nth term?
3m plus 1.
So it's always in the form an squared plus bn plus c. What is... So sub in a, b, and c for our final answer.
A is... What was A again? 3? Oh, sorry, 2.
So it's 2n squared plus
1.
1n.
Squared.
1n or just n plus...
No.
And c was term 0.
Oh, but so it's just 0.
No.
3?
The term before the first one in the sequence.
Oh, 1.
That's it. So this is this quadratic sequences. So in general, find the second term and half it to get A. Find the term before the first term to get C, and then use first term equals A plus B plus C to find the middle term, B. So
Yeah.
we need to practice this. I'm just going to skip all the easier ones and go here. Good. Okay, let's practice with this one.
So we just start by finding the difference between everyone,
Yep.
which in this one is.
And you can use a calculator for this.
So the difference between 8 and 23 is 15.
Yeah.
23 and 48 is 25.
Yeah.
And then it'll be 35
Yeah.
and 45.
Okay. What's next?
You got the difference between each is 10.
Yeah. So second difference is 10.
Then would you need to do 15 minus 10 to get the fast one, or the one that's before the fast one, like we did in the last one.
Okay.
So that's 5.
Yeah.
So would that be your n?
We need to now find the number in front of 8 using that 5.
So you do 8 take away 5.
Yeah.
Which is 3.
That's it. So C is 3. The second term is 10. How can you use that for something?
I don't know, to be honest.
And we have to find what A, B, and C is. The second difference is equal to 2A. So 10 is 2A.
So 8 equals 5.
Correct. So A equals 5. And how do we get B?
You can just do it now, can't you? So UN equals 5 n squared. Oh wait, no, I don't know. How did you get B actually?
The easiest one to use is U1. The first term is always A plus B plus C. A times 1 squared plus B times 1 plus C.
U1 is what? 8.
Yeah.
So B have to be 0 though.
So in this case, B is 0. Yeah. 5 plus B plus 3. And so what is our final answer for the nth term?
The final answer is UN equals 5n squared plus 0.
Yep.
Plus 5. Sorry, plus 3.
That's it. And you can always write it without the 0n. 5n squared plus 3.
Yeah.
Well done. Any questions there?
Not really.
Okay. I want to look for trickier ones. That one's okay. Let's try D, hardest one. So you can use those steps. How do we try D?
So we have to find the difference first. In this case, it's 8 for the first one. 14. 20. 26.
Okay.
So there's a difference of 6 between all of them.
Okay.
So, and what else I was do with the term 6? So what would you do? go back and do 3 minus 6, which is minus 3 for the first term.
No, it's 3 minus the first difference. The second difference is 6. So you'd use that to get the one before 8, and then use that to get the one before 3.
Yeah.
So try that.
The difference before 8 would be 2.
Yep.
The difference before 3 is minus 3.
You're thinking the second difference. You use the 2.
Oh, so we just do it minus 2.
Yep.
Which would be 1.
Yeah. And so that 1, is that A, B, or C?
C.
Yeah. So we need A, B, and C. We just said C is 1. What's next?
Oh, I forgot what the next step was.
The second difference is always equal to 2A.
Oh, so 6 equals 2A.
Yeah.
A would equal 3.
Yeah. And then we need B.
So U1 equals 3. So it equals 8.
I'll just write A plus B plus C.
Yeah. And the first one in the U sequence is 3, isn't it?
Yeah. So what is that in?
So you got to do A plus B plus C must equal 3.
Yeah.
So A is 3, C is 1. That has to be minus 1.
Correct. And so what's the final answer?
A equals 3.
And so what is the term-to-term rule? UN.
3n squared minus 1n.
Yeah.
Equals 1.
Plus 1.
Plus 1.
That's it. Well done. Tricky stuff. Any questions there?
No.
Okay. So this is tricky stuff. And I just want to keep doing the challenging ones and not go back. Yep. Oh. Excuse me.
So wait, what would you do? What would you do with that?
So we're trying to find the term-to-term rule for the y.
Oh, well, y equals x times 7.
Well, these are just so x is like n, and then this is an squared plus bn plus c, and you have to find out what is a, what is b, what is c.
Oh, I don't really know how to start with.
It's exactly what we were doing. So it's like a sequence of numbers: 7, 21, 43, 73, and 157. You have to find A, B, and C.
Well, there's a difference of in the first one, 14.
And I'll just be a sec. Go on, first difference and second difference.
So the first one's 14. Then it's 20.
Sorry, it's a bit noisy.
That's right. So it goes 14, 22, 30.
Okay.
Shows an 8 difference every time.
And so second difference of 8. Okay.
Yeah, so that's the second difference, 8.
Mm-hmm.
Then I don't know what you do next. Oh god, yeah, you do thing you take away 8, 4, 7 take away 8. Don't you?
First difference first, and then go back to the original. So 8 is the second difference. You need to work out. You need to take away from 7 the first difference for that.
It's the first difference.
Well, after 7 it was 14. After that 22. So basically, what number is before 14, and then what number is before 7?
Oh, the number before 7 would be -7.
What number would be before 14?
6.
And so that's the number you use for the 7.
Ah. So then 7 take away 6 is 1.
Yeah. And so it's like 1 plus 6, 7. 7 plus 14, 21. 21 plus 22, 43. Okay. What's next?
Then would you have to do 2a equals 8?
Mm-hmm.
So a would equal 4.
Yeah.
And since equals 4, then you would do u to the power of 1 equals, that would have to equal 6, wouldn't
it? Well, we found A. We also found C. What is C?
Would it be -6?
No. C is the number before 7.
Oh, 1.
Yeah. So C is 1. We said A is 4. And how can you now find B?
By doing, you've got to do 8 plus 4 plus something equals 1.
Well, equals U1, the first term.
Wait, so what have you got to try find?
B. So what is U1?
Oh, if you're only finding B, oh wait, so you got to do, no, but like, what's the overall number that A plus B plus C's got to add up to?
U1, the first term.
Which is, oh wait, so it'd be -4.
No. What's the first term in the sequence?
7.
Yep.
Oh, so it would be 2.
That's it. And so B equals 2. And so what's our final answer for the nth term?
It would equal 4n squared.
Mm-hmm.
plus 2n plus 1.
Well done. Yeah, so in general, find the second difference and then half it to get A. Use the second difference to get the first term, which is C. And then the 0th term to get C, which is C. And then the first term, 7, in this case, is always equal to A plus B plus C. And solve it from there. So let's try. I'll try question 1. Except this time I'll just take in the sequence of numbers itself. So it's the exact same idea. Oh. Okay, nth term for this quadratic sequence.
Would the So the nth term is just 9n minus 2.
You're thinking of a linear sequence? This is quadratic?
Oh, sorry, the difference is 9 for the first one.
Mm-hmm.
10. Sorry, 9, 13,
Mm-hmm.
17, 20, 1,
Yeah.
and then 30. No, it wouldn't be. Would it just be 25?
Yeah. What's next?
I don't know.
Second difference?
Oh, so yeah, the second difference is 4.
Yeah. Okay, go on.
I don't know what the next difference should be.
How do you use 4 to find A, B, or C?
Oh, G divided by 2.
Yeah.
So A is 2.
Okay. A is 2. What's next?
So, like, isn't C just 4? Like, I don't know.
C is always the very first term. Sorry, term 0.
So it would be. So would it be 3?
So that would be you would use the first difference. So you have to use 4, the second difference to get the first difference, and then the first difference to get C.
Well, for that one where it's 9, 13, the difference is 4. So you'd need to do 7 take away 4.
That's second difference. What's the number before 9 in the first difference?
Oh, yeah, 5.
Yeah.
And you do 7 take away 5, which is 2.
Yeah. And that 2 represents
C.
Yeah. And lastly,
You need to find B.
mm-hmm. And so how do we do
that? Well, it needs to equal what? So, it needs to equal. Is it 9 or 7 overall?
No. So for B, so U1, if you sub 1 into an squared plus bn plus c, you get a plus b plus c. So how can you use that to get B?
What does U equal? Is U just 7?
Yeah, U1 is 7.
So B would be 1.
So what is A? What is C?
A is 2, C is 2, so it would actually be 3.
That's it. And so what's your final answer?
2u squared.
2n squared?
Oh, sorry, 2n squared plus 3n plus 2.
That's it. Any questions there?
No.
Okay. We need practice. I just want to see. Yeah. Okay. Let's try a tricky one. Let's try. So let's see what the numbers are like. Yeah. Let's try question 7.
So which is 7 for the first one,
Yeah.
13 for the next, then 19, 25, 31. So you've got to find the difference between them is 6 every time. So then you've got to do 6 divided by 2, which will give you A, which is 3. So A equals 3. Then would you have to do 7 to take away 3? The second difference you've got to take away from the first difference.
Yeah.
Which would give you 1.
Yeah.
And then you've got to do 3 minus 1, which minus 4 would be the first one.
Or the 0th one.
I'm sorry?
Yeah, go on.
So would that be what A is, minus 4?
A is 3. Minus 4 is
C.
Yeah.
So then you need to do whatever you can to get to minus 3.
Now so we have A and C. We only need B.
2.
So minus. So how did you get to?
Because 3 add minus 4 add to minus 2 equals
minus 3.
Yeah.
And so B is
B is minus 2.
correct.
Right.
Yeah. It's just the first time you said B is 2. I was just checking.
Oh yeah.
Yeah. So B is minus 2. And so what is your final answer?
U1 equals 3n squared minus 2n minus 4.
Well done. That was a very tricky one because it's got 2 minuses and an odd number for A. Any questions there?
No.
Okay, so in general, how do you find the nth term of a quadratic sequence?
You find the difference between. You find the first and second difference. A is half the second difference. C is whatever the first sequence is, take away the second difference. You take that away from the first sequence.
Mm-hmm.
And then B is just a sort of connect the dots thing.
So there's a special way of finding B. Well, what's the way that I use? I'll just write it down.
Is B just what you do to fill in the sequence?
So that's the way you're doing it. So you found A, then you found C. Then what did I write down next?
UN equals.
U1 equals?
Yeah, sorry.
And what was it equal to?
The first term, the first sequence.
Okay. And in that same equation?
I don't know.
See. This is what I'm showing here. So it's just, you always do it in an intuitive way. And just making sure that you'll remember it. The first term, U1, so in this case -3, but in general, the first term is always A plus B plus C. And so you can sub in the first term for U1, A into A, C into C, and then solve it for B. Because you might get tricky numbers. So find A, find C, and then sub U1, A, and C into U1 equals A plus B plus C, then solve for B. Any questions there?
No.
Okay, so that's as hard as sequences gets. It didn't used to be taught at GCSE, and then if you go back way back, it was taught at GCSE. So for arithmetic sequences, you're okay. So an arithmetic sequence or a linear sequence, that in general, it's dn plus c, which is like y equals mx plus c. And hi, can you hear me? Hi, can you hear me? Are you able to hear me? And geometric, and quadratic, dn plus c and an squared plus bn plus c. These two are the same. C is the same for both of them. It's term 0.
Yeah.
So for this one, C was -1, and you can see the term before 3 minus 4 is -1. Was there anything else? How do you show that a term is not in a sequence?
You find the number that it says is in a term.
Mm-hmm.
You then, well, first of all, you find out what the actual sequence is.
Mm-hmm.
Then, whatever the number is, add or minus. You do the invert of that sign, and so
you solve it.
Example, if it was 3n add 7 equals 500, then you do 500 take away 7 equals 3n.
Yeah. So you'd solve it, and then
you would just divide it by the amount of numbers that are behind the n.
And how would you know if it's in the sequence or not based on your answer?
Because it would be divisible by an integer.
Yeah, either it would be an integer or not. Fibonacci sequences, you're okay. For subbing in this one, you're okay. And then we did these hardest ones, which are quadratic. So
yeah, that's not hard.
So A is half of the second difference. C is term 0 before the first term.
Yeah.
And then B is term 1, take away A, take away C.
Yeah.
How did you find that, James?
It was really helpful, thank you.
Okay. Anything in particular you want to do next time?
Could we do simultaneous equations?
Yeah. So,
Right. Yeah.
and I'll probably do quadratic simultaneous equations as well.
Yeah, that's fine. All
Any,
right.
any questions for me in general?
Not really, to be honest.
Okay. Well done, James. You're doing great. I look forward to talking again next time.
Yeah.
All right. Have a good one. Goodbye.
Bye.